I have started this series, The Language of Gods, where I would be explaining different complex mechanisms and little intricacies of programming, and vital programming concepts that lie at the root of enterprise programming solutions. That will help you create beautiful designs as if you are painting like Bob Ross, and solid architecture principles that will help you establish a strong position in this art. Well, I did not mention the language that I will be using, did I? Like a good architect who defers the least important decisions until they are really required. But it would be Java, as it is my favorite programming language. And today's topic is... So we will be discussing this in 8 sections, and I will also provide timing for each section in the description below so that you can jump to a section of your choice if you come back again. First, we will set up some problem statement and try to solve it with a preliminary approach. Also, we will study what is a simple factory after that. Then we will move on to study factory method design pattern. We will also study how this design pattern can help us in independent development and deployment of applications. Then we will study a bad contract dilemma. After that, I will try to give a shot at explaining dependency inversion principle. And then I will be explaining why type safety can be a pain in the ass sometimes. I will finally explain what is abstract factory design pattern, for which we will be creating a long base in this video, as the concept is quite simple, but the explanation will require a base to build up. And then I will give some conclusive notes about whatever I have explained in this video. Do try to make notes of that if you really want to remember them later. Well, this brings me to my opening point. What problem statement do we have? Let's set up some base example for our problem and we will follow along this example. Assume we have a franchise of automobile, say Ford, and we have various cars being produced and sold across different places. We need to create a website for the same. We start our website creation by first creating the vehicle interface, as we saw earlier in the diagram. We provide some methods to it. Let's say assemble, register, test, pack, etc. These are abstract methods and will have to be implemented by all of the concrete car models that this company currently provides, which is actually Mustang, Aspire and Figo, as this is a Ford company obviously. So we create a Enums car model for these 3 types. Now these cars are currently supplied at 2 different locations, so we have to create enum for the same. Let's say India and USA currently. I have chosen India and USA for a specific reason. Now the company says that we will have a showroom, and from that showroom you can buy the vehicle, and showroom will be at different locations. So we will create the showroom class for the same. The showroom class will have a location and we can buy the vehicle from the showroom. So depending upon the locations or the car models that you want, you will have created 6 different concrete implementations in this method. I have created Indian Aspire and American Aspire separately because actually they are 2 different vehicles. Although they are Aspire, but in India we drive it on the different side and in America on the different. Now we call different methods on this vehicle class. So we say register, assemble, test being called over here, and finally we return the vehicle. So we will have to create a client which will consume this showroom. So we create a client. This client instantiates the class showroom with say location India. So this is an Indian showroom. Now he wants to buy the vehicle. So the buy vehicle method is being called, and let's say we want car Figo, which can later be driven obviously. So if we call this main method, we will see that the Indian Figo got created. Also the other methods that this buy vehicle was calling were actually also called. So vehicle was registered, assembled and so on. These were actually the contract methods that were supposed to be called before you buy the vehicle out of the showroom, and later you could drive that vehicle. So Indigo Figo was actually driven. So yeah, we are done with this right now. So far so good. Birth of a simple factory. Now our code starts working until our company decides to launch a new car model, which is like every year or so. What are the things that we will need to change in our current design of code? That's when it hits us. What an inflexible piece of shitty code we have written. We will have to add another car model in our enumeration, which will also be the base for our discussion on type safety battle. But right now, we would need to change the buy vehicle method every time a new location gets added or a new car model is being supported by the showroom. Our code is inflexible and is violating a common principle that states classes should be open to extension but closed to modification. Well, this gives the birth to our simple factory. The work of simple factory is to take out the creation of a particular kind of object away from the area of the code which is going to consume that concrete object. Let's dive right into the code. We have our showroom class. Inside it we have buy vehicle method, which actually creates the product, performs some contract steps on this product, and then returns the product. If you focus on the code from line number 23 till 31, you will find that this piece of code does nothing but just creates the concrete implementation of the vehicles we have. Now, our principle states that we should separate the code responsible for the creation of concrete objects away from the code which is actually consuming it. So we create another class calling it simple vehicle factory, which is very similar to the showroom code, but instead of buy vehicle, we are just creating vehicle over here. And what we do, we cut the code from the showroom class from line number 23 till 31 and we paste it inside the simple vehicle factory that we have created. Now we go back to showroom class and we instantiate the vehicle using the simple vehicle factory that we have created. Now nothing has changed from the showroom client's perspective. If we run the main method for client, we still get the same output. Well, now you have your heads turning. Why? I know. Well, you would say that, well, you just move the code from one class to another class. Now, instead of changing in this class, you will be changing the code in another class. Isn't it an unnecessary suppression of code while shifting the burden from one code area to another code area? Well, that makes sense. But what if there is another client that can consume the same code now? What if instead of showing the car in the showroom, you want to launch the car at some auto show? Let's see this auto show code over here. Instead of buying vehicle, you just display vehicle. If you see line number 19, this is exactly similar to that of in showroom class. We are just calling the simple vehicle factory to create the vehicle. Now this simple vehicle factory is responsible for creating the vehicle for both auto show and showroom class. Well, changing at one location will help us reflect the changes in both auto show and showroom class. Isn't that just wonderful? Welcome to franchising the store, the factory method. I can see some more improvement that can be done. We have come from a highly coupled code to a little less coupled code called simple factory. Well, we can go a step further and start creating the franchises of the factories as per the location, so that when a new location gets added, the existing set of factories don't have to change and start accommodating these clumsy ifs in those location based factories. So we had this simple factory which was depending upon the location. We take this create vehicle method from this factory and create an interface that will have this abstract method create vehicle that will be implemented by concrete location factories like Indian factory, and American factory. We have created a showroom franchisee code that does not depend on the location anymore, but instead depend upon the interface that we just created called vehicle factory, which can be instantiated by the concrete implementation at runtime. This is called programming to interface rather than programming to implementation. If you see the showroom franchise client, you can instantiate the factory with either of the two choices and run it. You will see the concrete implementations being created accordingly. So when a new location is added, We don't need to touch the existing factories. You just need to create another implementation class, let's say European factory. And the instantiation of vehicle factory by the concrete implementations can be done at runtime depending on the location that you are running the. Let's look at this wonderful diagram for factory method. We have an abstract factory, which is actually a vehicle factory in our case, that depends upon an abstract interface for product. Vehicle interface in our case. Now, abstract factory has two concrete implementations currently. Concrete implementation of Indian factory and another concrete factory, American factory. Now, abstract interface, the vehicle interface, has two concrete product implementations. Although we have 6, but we are going to draw only 2 right now. Indian Mustang and American Mustang. American factory creates American Mustang. Indian factory creates Indian Mustang. We have a client over here that will instantiate the abstractions by their implementations at runtime. Isn't that just wonderful? So this is the diagram for factory method design pattern. Independent development and deployment. If we look at the diagram that we discussed in last section closely, we can draw a line of separation in between, which allows us a wonderful thing. The components above the red line have no idea about the components below the red line. That gives us one more special feature of factory method design pattern. You can deploy the code above the red line separately and develop the code below the red line separately. As you have developed them separately, you can deploy them separately. The component below will just need to have references to two abstract components above the line. What special feature do we get out of this? If we make changes below the line, let's say if we add another European factory or add another concrete vehicle that will be created by one of these concrete factories, you will have to make no changes above the red line instead of the enum that is lying around above the line, which will be our topic for type safety battle. Till then, let's quickly discuss what is a bad contract dilemma, and which is another approach to address factory method design pattern. Bad contract dilemma. We have another approach to deal with this factory method design pattern. When you had just the simple factory, you could use that simple factory and then that would be it. That could even be made static, which would allow you to separate the object creation from the client code, but you would still be stuck with that implementation only. But now what have you done is you have created a factory that is abstract. You can compose your objects on the fly with that whatever implementation of the factory you would like. This actually solves the problem, but this can give a bad contract to the user. Look at this bad client example, where the client is directly using the factory to create vehicle instead of going to the showroom method for the contract methods to be called. It directly calls the create vehicle method and starts abusing the vehicle after creating the vehicle. You would like a little more quality control on how our objects are created, and define a contract that specifies what is done and takes out how it's done. To implement this, we have set up a new structure. So instead of showroom class using the vehicle factory to create the object, the showroom class itself becomes the abstract factory. Then we have the control of what shall be done after the object is created, and leave the creation of the concrete product on the implementation of the showroom class. We have the implementation as Indian showroom, which creates Indian products, and American showroom, creating American products. If we look at a good client example now, the client code will now instantiate the showroom with one of the implementations and calls the buy vehicle method out of it. This gives a proper contract to the client. This is another example of factory method design pattern, where abstract factory is the showroom and the concrete factories are Indian showroom and American showroom. Dependency inversion. If we look at the showroom class that we had written earlier, the showroom class was highly dependent upon these vehicle concrete implementations classes, 6 here for now. So if we look at the dependency flow from the showroom class to these concrete implementations, we will see the arrows going downwards. But now, after the factory method implementation, the showroom code depends upon the factory depends upon the vehicle interface, and the classes, the concrete implementations that we had, are not depending upon the vehicle interface. So arrow goes from these concrete implementations toward the vehicle interface. So if we compare the two diagrams, the dependency flow going from top to bottom has inverted going from bottom to top. And if we draw a line between these concrete implementations and vehicle interface, we can deploy them separately. The type safety battle. If we look at the diagram that we explained in the section independent development and deployment, we will see that the code above the red line was able to be deployed and developed separately, and the code below the red line differently. But we discussed that enum lies above the red line because it is a form of abstraction. If you see this enum lying above the red line, a thought should immediately come to your mind. What will happen if the company wants to produce a new car model and one of the concrete implementations start producing that concrete product, let's say car Endeavour? We would have to add this Endeavour to the enum above the red line. The change below the red line is causing a change above the red line. Adding concrete implementation below the line will cause an enumerator to be added in the enumeration above the red line. Well, what property does enum provides? Type safety, right? The type safety between the two layers is the last link that is causing hindrance in the independent deployment. What would happen if we remove this type safety parameter and convert it into a string? The new factory method implementation now accepts a string argument and also has a method that specifies what set of strings can it accept. Well, you might be thinking, this guy has gone mad. He's removing the type safety, which can cause runtime errors. Well, yes. You can actually handle them while writing JUnit, right? I mean, that is what JUnit is supposed to do. Solve the problem of runtime errors. Well, yes. The last link that was holding them together was this type safety. Without removing this, you can never call it 100% separation. That's why I call it the type safety battle. Well, all of this till now brings me to my final point, that is abstract factory design pattern. This design pattern is actually based upon the factory method design pattern that we just studied. While the factory method is responsible for creating one single concrete object, whereas the abstract factory design pattern allows you to create a family of similar products. Let's look at an example. We have this vehicle abstract class. I have added two attributes, wheel and door, in this vehicle abstract class, although it would be containing many more. But let's focus on just two right now. Wheel and door are two abstract classes which shall be instantiated by their concrete products by one single factory. A single factory will be responsible for instantiating these wheel and door for a vehicle, thus creating a family of products at one go. Let's look at this assembly factory. This is just an abstract factory, but instead of creating one single product, it will be creating door and wheel, a family of products. And look at this Indian assembly, which is extending assembly factory. This Indian assembly is very much similar to an Indian factory, which was having one method, create vehicle. But here we have two methods, create door and create wheel. And look at this example, Indian Aspire, which is extending vehicle. Now it depends upon an assembly factory, which is an abstract factory. If you look at the method assemble, it is calling this create door and create wheel method from the same factory. So if we instantiate this assembly factory by the Indian factory, it will be able to create families of product and instantiate them for this Indian Aspire product. Look at this client code. It is exactly similar to what we have previously seen. But if we go inside this Indian factory that we are instantiating the vehicle factor with, we will be able to see that the Indian Aspire and Indian Mustang are now accepting an abstract assembly factory, which is actually instantiated by Indian assembly here. Now if you look at the showroom franchisee code, it is exactly similar as it was earlier. But this time, when this assemble method of this vehicle will be called, it will internally call the assembly factory, and that will instantiate the door and wheel object for this vehicle. Well, now you can pause the video and look at this abstract factory design pattern diagram, which is exactly similar as it was earlier for factory method. But this time, instead of just one method, it is having more than one methods. For this example, we have taken two to create door and wheel. So it is able to create a family of products. Hey, so we are almost at the end of the session. We will be discussing all the subsections that we went through in just one-liners, which will only make sense if you watch the whole video. So what is an abstract factory? Abstract factory provides an interface for creating families of related or dependent objects without specifying their concrete classes. Factory method defines an interface for creating an object but letting subclasses decide which class to instantiate. Factory method lets a class defer instantiation to the subclasses. All factories encapsulate object creation. Simple factory, while not a bona fide design pattern, is a simple way to decouple your clients from concrete classes. Factory method relies on composition as well as inheritance. The first example we saw was based on composition, but later we changed it to inheritance when we studied a bad client example. In that example, object creation was delegated to the subclasses, which implemented the factory method to create the objects. Both are actually valid way of factory method design patterns. Abstract factory is just an extension of composition factory method design pattern. It relies on object composition. Object creation is implemented in the methods exposed by the factory interface. All factory patterns promote loose coupling by reducing the dependency of your application on the concrete classes. The intent of the factory method is to allow a class to defer instantiations to its subclasses. The intent of abstract factory is to create families of related objects, which is similar to factory method, but instead of creating just one object, you create related dependent objects. The dependency inversion principle guides us to avoid dependencies on concrete types and to strive for abstractions. I would repeat that, strive for abstractions. Factories are a powerful technique for coding to abstractions and not concrete classes. Please like, share and subscribe my video. Don't forget to hit the bell icon below to receive notifications whenever I upload next video. And you can drop your questions in the comment sections below. See ya.